We're going to practice on some systems of equations. We covered the method of addition and the method of substitution. So let's practice on these. The first system that we're going to solve, I'll call it 201. Okay. You have 4x minus y in the first equation, then you have 2x plus 5y in the second equation. We can choose to eliminate x or y. If we want to eliminate y, we have 5y here, so we shoot for minus 5y. It means we need to multiply this equation by 5. So multiply the first equation by 5. But if we choose to eliminate x, we have 4x here, we shoot for 4x here with a negative in front of it. So what do we multiply this to get minus 4 by? We multiply it by negative 2. So you multiply the second equation by negative 2. You don't need to do both. So multiply the first equation by 5 or the second equation by negative 2. Okay, let's multiply the first equation by 5. So if you multiply the first equation by 5, make sure every one of these numbers is multiplied by 5. So times 5, times 5, times 5. And that will give us 20x minus 5y equals 15. Add these equations. 2x plus 20x is 22x. The y's cancel. 7 plus 15 is 22. Divide both sides by 22, and that gives you x equals 1. Once you get x equals 1, you have 3 choices of equations where to substitute. You can substitute in the first equation, second, or third. Pick, it doesn't matter which one you pick. Let's pick the second one. So 2x plus 5y equals 7. All right. 2 times 1, we got x equals 1, plus 5 times y equals 7. So 2 plus 5y equals 7. Subtract 2 from both sides, and that gives you 5y equals 5. Divide by 5, and that gives you y equals 1. So the solution is x equals 1, y equals 1. And you can write it like this, 1, comma 1, and the problem is done. In this system here, if we choose to eliminate y, let's say, we have minus 3 here and 6 here. If we multiply the first equation by 2, we'll end up with negative 6. So let's multiply the first equation by 2. And don't forget to multiply everything by 2. 8x times 2 is 16x. Minus 3y times 2 is minus 6y. 15 times 2 is 30. Look at these two equations and add them up. When you add them up, minus 16x plus 16x will give you 0. The y's will give you 0. But the right side is 32. 0 equals 32 is a contradiction. That means it doesn't happen. So this system here has no solution. If you end up with a contradiction, it's always no solution. Let's solve a system of equations with fractions. 1/5 of x minus 1/6 of y equals 4, and then 1/6 of x minus 1/4 of y equals minus 2. When you have a system of equations with fractions, what you want to do is simplify the equations and get rid of the fractions. So look for a number that can be divided by both 5 and 6, like a common multiple. It doesn't have to be the least common multiple. Any common multiple will do. 5 times 6 is 30, so I'm going to multiply the first equation times 30. And the second equation, I'm going to multiply it by 12, because 12 can be divided by both 6 and 4. So times 12. When you multiply, make sure you multiply every term by 30. So you multiply here by 30, here by 30, and then here by 30. And then 12 times, 12 times, 12 times. 30 times 1 over 5 is 6x. 30 times 1 over 6 is minus 5y. 4 times 30 is 120. 12 times 1 over 6 is 2x. Minus 1 times 12 over 4 is 3y. Minus 2 times 12 is minus 24. Now we have a system without fractions, but we still need to do something about it to solve it. Look at the second equation. It has a 2x here. First equation has 6. If we want to use the addition method, we could multiply the second equation by minus 3. So 2 times minus 3 will give us minus 6, and it cancels the 6. So times minus 3. Second equation. Times minus 3. We leave the first equation alone, okay? 6x minus 5y equals 120, and then 2 times negative 3 is negative 6. So times negative 3 times negative 3 times negative 3. Minus 3y times minus 3 is plus 9y equals 24 times minus 3 times a minus is 72. Add these equations. So add minus 5y plus 9y is 4y. Okay. 120 plus 72 is 192. Divide both sides by 4, and that gives you y equals 48. We have so many places we can substitute y equals 48, and we have 6 equations. These two, and these two. I don't want to substitute in the original equations. I usually want to, but they have fractions. We could, so let's substitute in another equation. We want to solve for x. Let's substitute in this equation, okay? 2x minus 3y. 2x minus 3y equals negative 24. So 2x minus 3 times 48 equals negative 24. 2x, 3 times 48 is 144 equals minus 24. Add 144 to both sides, and that gives us 2x equals 120. Divide by 2, and that gives us x equals 60. So the solution is x equals 60, y equals 48. Or you could write it like this, 60, 48.